All right, today we start talking about area. Good thing is, most of us are pretty good with area. And these formulas, I'm giving them all to you here, but you don't need to memorize them. You'll have them on your formula sheet, assuming you haven't lost it yet. It's a good idea to think about why and how these make sense. But again, don't worry about memorizing them. They're on your formula chart. So it says, what does it mean to find area of a figure? What does it mean? Most of us know how to do it of a rectangle. What are we finding? What does it mean? Well, this gives us a pretty good picture here. It says, how do we find the area of a rectangle? Again, most of us know it's just length times width, but what are we finding? Again, what does that mean? Well, in this picture, we can see we're just counting the number of boxes that fit inside the rectangle. And that's really all we're doing. We're trying to find area. How many of these square boxes fit inside the shape? And again, most of us already know this, area of a rectangle, length times width, or you'll see it base times height. First practice problem. Find the area of a rectangle with the length of 12 inches and a diagonal of 13 inches. Okay, so let's draw the picture. So there's my rectangle with the length of 12 and a diagonal of 13. Again, my formula for area says nothing about diagonal, so knowing the diagonal in and of itself doesn't help us. We need to use that to find a missing piece. So if this piece is 13, that's my diagonal. Here's my length is 12. Well, this is just a right triangle. It's a Pythagorean triple, 5, 12, 13, so this width over here must be 5. So area is equal to length times width, which is just 12 times 5, so my area is just 60 inches squared. Alright, they give us this problem. Find the height of a rectangle with an area of 100 inches squared and a base of 40 inches. So I'm looking for my height. I know my area is 100, and I know the width or the base is 40. So area is equal to base times height. I plug in, area is 100, base is 40. I don't know the h. So I have 100 equals 40h, divide both sides by 40, and you get 2.5 inches equals the height. Again, rectangles, pretty straightforward. All right, parallelograms. This is important where that height is. Again, notice it's just the same as the area of my rectangle, base times height. It's the same formula for area of a rectangle. The important piece to remember is that the height of the parallelogram must be perpendicular to the base. So AD and BC are not going to be your heights. Your height is this side right here where I have the H, because that's what's perpendicular to the base. That's important, because if we go wrong on these, that's where we're going to go wrong. We're going to say BC is the height and multiply BC times this B at the bottom. We can't do that. The height is perpendicular to the base. Okay. Now, why should that be? Why should the area of a parallelogram be the same as the area of a rectangle? It doesn't look the same, so why is the formula for area the same thing? When you think about it, if I did a pair of scissors and I cut on this dashed line right here and I remove this triangle and I bring it right over here, that triangle will complete this rectangle. So it basically is a rectangle, just sort of in disguise. And I sort of cut it out for you on the next one to hopefully make it make more sense. Okay, so this one. Okay, there's my parallelogram. I still know that my area is the base times the height. And if we're not seeing that this is just really a rectangle, I cut it out for you and I taped it down right here. So I cut out this shape, I cut on the dashed line, and I just put them side by side, and so there's my rectangle. Now I think most of us will be able to see, well, this is my width, 18, and my length is 20, so the area of the rectangle would just be 18 times 20. Well, that's the same picture I've got here. It's the same thing. Area is equal to base times height, so it's 18 times 20, so it's 360 units squared. In parallelograms and rectangles, it's the same formula. This one just involves special right triangles. So again, it gives me the base. This was 12. It gives me this piece was 10. It did not give us the height. So I drew in the height perpendicular, which created a 30, 60, 90 triangle. And I could use special rights to get my height. Well, if this is 10, this is the side opposite the right angle, so this is the piece that equals 2x. So 10 equals 2x, so then x equals 5. And the x is the side opposite 30 degrees, so this piece must be 5. And the side opposite 60 is x root 3, so the height right here is just 5 root 3. So now I go to my formula. Area is equal to base times height, so it equals the base, which is 12, which we already had, times the height, which is 5 root 3. 12 times 5 is just 60, so it's just 60 root 3 units squared. Okay. Triangles, and again, most of us are pretty good with triangles. Area is equal to base times height divided by 2. But there are two different formulas. You'll see either one. I don't want you guys to be confused. You'll see one that says 1/2 base times height, and you'll see one that says base times height divided by 2. Multiplying by 1/2 and dividing by 2 are the same exact thing. So it doesn't matter which one you use. Again, just like with parallelograms, it does matter what you use for your height. Your height and your base must be perpendicular to each other. That's how you'll identify and recognize your base and your height. In a triangle, they'll be the two that are perpendicular to each other. Okay, so we go here. Find the area of a right triangle with a leg of 4 inches and a hypotenuse of 5 inches. So I draw my picture. There's my leg of 4, there's my hypotenuse of 5, but again, I need the base and the height. I need the ones that are perpendicular to each other to get the area. But I recognize it as another special right, a Pythagorean triple, 3, 4, 5. So if that's 4 and that's 5, this must be 3. So area is equal to 1/2 base times the height, 1/2 3 times 4, 1/2 of 12, which is just 6 inches squared. Alright, this one, they already gave me the area, and they gave me the base is 20, so I just need the height, this missing piece. So I have area is equal to 1/2 base times height. Again, they told me the area was 100. There's my 1/2. I know my base is 20 from the picture, and I'm trying to find the height. 1/2 of 20 is just 10, so I have 100 equals 10h. Divide both sides by 10, and you get that h is equal to 10 units. Alright, trapezoids. There we go. To get the area of a trapezoid, here's the formula. You take base 1 plus base 2, you add up your two bases, you multiply by the height, and then you divide by 2. So I've got it labeled here. It doesn't matter which one you label base 1 and base 2. But again, your bases are the ones that are parallel to each other. So let's call this base 1, this base 2. Again, what's important about the height is that it must be perpendicular to your bases. So these two legs are not your height. It's the section that's perpendicular to your bases. So this would be your h right here. Alright. It says find the length of the midsegment of a trapezoid with an area of 75 meters squared and a height of 5 meters. So there's my formula for area. Trapezoid area is equal to base 1 plus base 2 times the height divided by 2. So now I just plug in all my information. I already know the area is 75. I've got base 1 plus base 2, and I'm told the height is 5, and then I just divide it by 2. So to clear out this fraction, I multiply both sides by 2, and now I'm up here. So I have 150 is equal to base 1 plus base 2 times the height of 5. To clear this 5, I divide both sides by 5, and now I have 30 is equal to base 1 plus base 2. So now, if you remember, how do we find the length of a midsegment of a trapezoid? We add up the two bases, and then we divide by 2. Well, that's what I have right here. I already know that if I add up both bases, it's equal to 30. So what do I do to that to get the midsegment? I just divide it by 2, and I get 15. So 15 is my midsegment. All right. Find the area of the isosceles trapezoid. Okay, I'm given 4 as a base, I'm given 16 as a base, and I'm given 10 as one of the legs. I don't have the height, so I need to work at it. Okay, if it's 4, this top base is 4 all the way across from these two pieces is 4. Well, if I go straight down, it's also 4 from here to here. So that's what I've got labeled right here. It's 4 from this little mark to this little mark. But I already know from this 16 that it's 16 all the way across. And I know it's isosceles, which means it's symmetric. So if it's 4 from here to here, these two end pieces must be the same. And if it's 16 all the way across, and 4, again, I got that 4 from this 4 at the top, from here to here, this end piece must be 6. This end piece must be 6 to add up to 16 all the way across. So now, I know this piece is 6, I know this piece is 10, I draw in a perpendicular and I create a right triangle. And I recognize it as basically a 3, 4, 5 triangle. If this is 6, this is 10, this must be 8. So I just got the height of my trapezoid. So I go to my formula. Area is equal to base 1 plus base 2 times the height divided by 2. I know that one base is 4, one base is 16. I know my height is 8, and I divide it by 2. Put that all into the calculator, and you get 80 for your area. All right, rhombus. How do you find area of a rhombus? Pretty straightforward. You just find your two diagonals. So let's just call this diagonal 1 right here. Call this one diagonal 2. You multiply them together and divide by 2. So D1, D2 divided by 2. Area of rhombus, pretty straightforward. which we've got here. It says find the area of a rhombus with diagonals of 12 and 16. So if I already know my diagonals, area is equal to d1 times d2 divided by 2, which is equal to 12 times 16 divided by 2, which is just 96 inches squared. All right, find the area of this rhombus. Okay, this one we're not given everything, we're just given this piece is 10. But if it's a rhombus, okay, this piece must be 10 because the diagonals bisect each other. Okay, if it's a rhombus, I also know that my diagonals are perpendicular, so I do have right triangles right here, and I want this piece, this x. Just look at this right triangle here on top. I got a 42-degree angle here. I want this x, and I know this piece is 10. So I know this angle, I know the opposite side, and I want the adjacent side. That's going to be tan. So tan 42 equals opposite over adjacent. Tan 42 is equal to 10 over x, which means that x is equal to 10 divided by tan 42, which means x is equal to 11.1. So if x equals 11.1, that's from there to there, which means this is 11.1. So all the way across, I just add those two up. So that gives me the length of that diagonal. I already know the length of this diagonal. I multiply them together, I divide by 2, and I get 222.1. Area of a kite should look familiar to you. It's the same as the area of a rhombus. It's the same exact formula to find area of a kite. Multiply your two diagonals, and you divide by 2. Which, again, we can call that diagonal 1, we can call that diagonal 2. Doesn't matter which one you call diagonal 1 or diagonal 2. So this one, it gives me the two diagonals already. Find the area of a kite of diagonals 15 and 38. Well, if I know the two diagonals already, I just multiply them together and I divide by 2, and it gives me the area of 285 units squared. All right, find the length of the second diagonal if the area of the kite is 135. So I already am given the area, and I'm already given one of the diagonals. So then I already know that 135 has to be equal to d1 times d2 divided by 2. But I already know one of my diagonals. One of them is 14. So 135 must equal my diagonal 1 times 14 divided by 2. Multiply both sides by 2, you get 270 is equal to 14 times d1. Divide both sides by 14, and you get that d1 is approximately 19.3. All right, last one. How do you find the area of an equilateral triangle? There it is. If all your three sides, let's call the three sides s. Of course, if it's equilateral, all the sides are going to be the same. It's just s squared times root 3 divided by 4. And I've got that one on the front wall if you forget it. So now it tells me I've got side lengths of 12. So that's my side length. So I plug in and I do 12 squared root 3 divided by 4, which is approximately 62.4. Again, a lot more examples in class. Just come to class with an idea of what we're doing.